Ooh, good morning, everybody. This is Mr. Aynesworth here, and we're going to get into our part 2 video here, going over how to simplify expressions, trig expressions here using the Pythagorean identities, but also we get to a couple examples of how to prove things too as well. All right, in my first part of the video here, I went over all the Pythagorean identities. So if you haven't seen this one yet, well, then obviously you got to go through this too, because look at this. There's a lot, okay? And so in the first video here, I talked about the Pythagorean identities. I even added in a little review on the reciprocal functions and even odd functions. And then I went into 3 major examples. So right now, let's do a few more examples and get some more experience. Because experience is what you need. Okay, so here we go. I'm going to take secant squared theta, secant squared x actually, minus tangent squared x. What is that all about? Well, one thing we can do is we can rewrite in terms of sine and cosine. Because is that an identity? Let's see. Let's check our identities here. Let's go back in time here to do the flux capacitor, back in the future here. And we know that secant squared theta and tangent squared theta are related. Ooh, look at that. 1 plus tangent squared theta equals secant squared theta. So what do we have here? We have secant squared theta minus tangent squared theta. I'll tell you what. Let's take this identity here, okay? I'm talking about equation number 2, all right, that we developed. 1 plus tangent squared theta equals secant squared theta, and let's work with it here. All right, because the variation that I gave you here looks a little bit different. Okay, so what I'm going to do here first, instead of writing things in terms of sine and cosine, which we could do, I'm going to go off to the side and write down 1 plus tangent squared theta. Instead of theta, I'm going to write x here. All right, is equal to secant squared x. You can use theta or x. It really doesn't matter. The input variable, whether you use theta or x, doesn't matter. It's the concept. Okay, so now what do we have? So is this right here, the given here, secant squared x minus tangent squared x, is it part of this identity? Well, I'll tell you what, if we subtract tangent squared x on both sides, look at this. We get 1 is equal to secant squared x minus tangent squared x. Holy cow, this is equal to 1. Wow, that is amazing. Okay, so you can go ahead and rewrite in terms of sine and cosine. In fact, you know what? If you didn't know, let's do that just for because you might have not have seen that. So let's take secant squared x and write it as 1 divided by cosine squared x. Let's take tangent squared x and write it as sine squared x divided by cosine squared x. Okay. Now let's combine fractions because the denominators are the same. So we get 1 minus sine squared up top. Again, we're subtracting fractions here, right? You just subtract from left to right. Okay, do grade school math. And divide that by cosine squared x. And guess what? We also know another main identity. Your main Pythagorean identity goes like this. Cosine squared x plus sine squared x is equal to 1. Well, if you subtract sine squared x, that tells you that cosine squared x is equal to 1 minus sine squared x. So the numerator is just cosine squared x. And when you divide it by itself, you get 1. All right? You get 1. So again, just combine the numerators, or rewrite in terms of sine and cosine, and then combine the numerators. Use your Pythagorean identity, okay, from here to here. This is called the Pythagorean identity, as you guys already know from my previous lesson. And then you apply it. So if you know your identities, we could have got 1 immediately. All right, but if you didn't see that, then you rewrite in terms of sine and cosine. So that's what I explained in my first video. Rewrite in terms of sine and cosine. And when you do that, you just use your basic arithmetic with fractions and use your identities, and you'll get 1. So this whole thing is equal to 1. All right, what is the next one equal to? I don't know. Let's find out. I really don't know because I haven't done this. I haven't done this in a long time. I'm just going with the flow. I know I'm the instructor, but I'm just going with the flow. All right, now the numerator is not the Pythagorean identity. This is cosine squared x minus sine squared x. All right, divided by secant. So the numerator is not equal to 1. That's a very, very common mistake. All right, it is not a sum, it's a difference. So the numerator is not equal to 1. All right, so I'm going to make a little note of that. Okay, not equal to 1. Not the Pythagorean identity. Not Pythagorean identity. And I'm talking about here. Okay, the numerator. All right, so now what do we do? Well, what do we do? Well, one thing that we can do is rewrite everything in terms of either sine or cosine. So cosine squared, well, secant is 1 over cosine. I can rewrite sine squared in terms of cosine. Maybe that's the approach. Okay, so here we go. I'm going to rewrite sine squared. I'm going to take my Pythagorean identity here, and I'm going to isolate sine squared. So sine squared x is equal to 1 minus cosine squared x. Okay, so I'm going to rewrite this. So I've got cosine squared x first, minus sine squared, but I know that the sine squared function is 1 minus cosine squared x. So 1 minus cosine squared x, and notice that I put in parentheses here, divided by 1 divided by cosine x, because secant is 1 over cosine x. So let's simplify up top and see what happens, because I really don't know. So cosine squared x minus 1 plus cosine squared x. Actually, let's not write it as a fraction. Let's just multiply by the reciprocal. So all of this here times the reciprocal, which is cosine x. So I kind of did 2 steps at once. I distributed through here, okay? Distributed through, and I got this quantity here, and then I multiplied by the reciprocal. Multiply by the reciprocal. In higher level math, believe it or not, there's a lot of lower level math. It's called arithmetic. All that stuff you learn in grade school. All right, now before we multiply these two things, we got to simplify it, right? So, I thought this was going to turn out to be something kind of cool, but it doesn't look like it's going to be turning into something kind of cool. Let me see. Secant x. Well, all right, I'm just going to go with the flow. So I got 2 cosine squared x minus 1 times cosine x. And if you distribute through, you get 2 cosine cubed, actually. All right, cubed x minus cosine x. Nothing great. This is a weird example. Doesn't simplify to something really nice. Yeah, not too fan of that one there, right there. Okay, all right, let's move on. Let's move to example 6. All right, now here, this looks familiar here. Cosecant squared minus 1. Let's go back to our main identities here. I'm talking about on the first page. Okay, do we have an identity for that? Okay, so, oh yeah, we do. Look at this, equation 3. Cotangent squared x plus 1 equals cosecant squared x there, or theta. And that means that cosecant squared theta minus 1 equals cotangent squared theta. Ooh, there is an identity right there. Okay, so cosecant squared theta minus 1 equals cotangent squared theta. That is an identity. So here we go. So I'm going to write that out. So cosecant squared theta minus 1 is equal to cotangent squared theta. Okay, this is equation number 3. That's why you kind of have to have these things memorized. And so this is equal to the square root of cotangent squared theta, which is equal to cotangent theta, and you're done. All right, the key is you got to memorize your identities. Memorize, all right? your identities, because if you don't, you won't be able to see this right here. You won't be able to make that little substitution to make it simple. All right, you'd have to go back to basics and rewrite in terms of sign, which would get messy. If you just want to see that, you would look like this. So if you didn't see that, you'd have 1 divided by sine squared theta minus 1. And then you would have to have common denominators. So you had a 1 over sine squared theta minus sine squared theta over sine squared theta. You just rewrite 1. Combine fractions. So you have 1 minus sine squared theta over sine squared theta, which, well, the numerator is cosine squared theta. The denominator is sine squared theta. And then you square root them. You get cosine theta divided by sine theta, which gives you cotangent theta. So do you want to rewrite in terms of sine and cosine, like I did here? Rewrite in terms of sine and cosine and do it this way, okay, which is obviously the long way to do it, okay? Or this is an or right here, sorry. Or do you want to just know your identities and make a simple substitution? So you decide. All right, number 7, here we go. If secant squared theta equals 4, find all these other functions. Well, I know that secant is the reciprocal of cosine, so I'm going to brainstorm here because I really don't know how to approach this. So if you reciprocate both sides, I know that cosine theta is equal to 1/4. I've talked about this in class. If you have a reciprocal or an equation here, you can reciprocate both sides. I don't know why a lot of kids don't know this. Reciprocate both sides of the equation. I mean, it's like just a basic technique that you should know. Now, if you know that, then you should be able to find these other ones, right? So, cosecant theta. What's cosecant? Well, let's go back to the Pythagorean identities again. Okay, so let me see. Let's brainstorm here. So, cosine squared theta is equal to 1 minus sine squared theta. If you square root both sides, cosine, actually, I want to do the other one here. I want to solve for the other one. So let me rewrite it. Sine squared theta is equal to 1 minus cosine squared theta. And so that means if you square root both sides, you get plus or minus the square root of 1 minus cosine squared theta. So in that case, you get plus or minus 1 minus 1/4 squared. Okay. So plus or minus, I don't know, that's 1 minus a 16th, right? 1 minus 1/16, that's 15/16. So plus or minus the square root of 15/16. So that's plus or minus the square root of 15 over 4. There's your sine squared theta. And then you reciprocate that to get, this is sine of theta. And then if you reciprocate that, you get cosecant theta. Is 4 divided by rad 15 if you just reciprocate that. Crazy problem. And then we got proofs. I'm going to have to do this in a 3-part video here. Okay, I'm going to come back to this one. I didn't realize I was giving you guys this kind of stuff. This is good stuff. All right, we're really going to have to practice how we do things. And then cotangent, well, that's just sine over cosine, right? So what's the easiest way to do this? So sine, so I know sine, I know cosine. Cotangent is cosine over sine. Cotangent theta is cosine theta divided by sine theta. So it's 1/4 divided by this other answer, plus or minus root 14 over 4. And then if you simplify that, you get 1/4 times the reciprocal, which is 4 over rad 15. And then you get plus or minus 1 over root 15, because the 4's cancel. And you get, I guess you get rad 15 over 15. Crazy problem. Okay, that takes some experience, or takes some practice. Not experience, but practice. Okie dokie. All right, I'm going to do this 3-part video series because I don't want the videos to be too long. So this part here will be part 3, where you have to prove, where you'd have to take a look at some proofs. Like how do you prove something to be true? All right, using the Pythagorean identities. We'll do that in part 3. Okay, that was a lot. Holy cow, I didn't realize it was going to be that much. So this is Mr. Aynesworth here. There's a lot involved here, as you guys can tell. So go ahead and practice well at home. It's one thing taking notes, but it's another thing understanding it. So always apply what you learn and pick up the pen and actually practice. And I'll see you in my next video, or hopefully in class. Take care.